Hi, welcome to Qubercomm's NMesh Demo. The problem we're looking at is in your home, the Wi-Fi signal decreases as the distance from the router increases. So how do you solve this problem? Adding routers to each place which needs extra coverage increases cost and complexity. And the solution that Qubercomm has thought of is, why not make any wireless device that you use into a mesh node so you can extend coverage without any added cost and no complexity. So this is Qubercomm's NMesh solution, and we'll be demonstrating this solution now. This demonstration is being done in a home, which you can see on the screen. It is spread out over 3 floors. On the ground floor, we have one mesh node which covers the about 800 square feet area of the ground floor. On the first floor, there is another mesh node which covers about 800 square feet area. On the second floor, there is a third mesh node which covers about 500 square feet area of the terrace. Now we'll start with, and this machine is the DUT, the laptop on which you're watching this is the device under test. It consists of a mesh node which is attached to a laptop. Now let's look at how the mesh nodes are connected. So this is the path selection page on the NMesh cloud. And on this page, you can see how each of the mesh nodes are connected to the other nodes. So the device we choose now is the DUT. And you can see on this page, on the top table, that the DUT is connected to the mesh node on the ground floor, which is the DMesh route, over 1 hop, to the mesh node on the first floor, also over 1 hop, and to the mesh node on the second floor, over 2 hops. That is, it is connected through the first floor mesh node to the second floor mesh node. Now we'll play a video from a video server which is connected to the mesh node on the ground floor, and we'll see how it plays and what the frame drops and other statistics related to the video are. The video being played is a 100 megabits per second bitrate video. So now let's look at the video being played. Now the video has ended. Now let's look at the stats, video stats on the NMesh web page. So we can see that the frame drops over the duration of the video has been around 60. The purpose of showing this statistic is to compare with the open source 11s solution. And now, as part of this demonstration, we'll take the device around the house and we'll show how the path selection algorithm that Qubercomm has patented will allow for better throughput and therefore better video quality in all parts of the house, and we'll compare it with the 11s solution and we'll see what the differences are in terms of the statistics and the frame drops. So let's move to the second floor of the house and we'll see how the path selection changes. Now we are in the second floor of the home, and now we're going to look at the path selection metrics to see how the path from the DUT to the video server on the ground floor has now changed. So on this page, you can see on the first table on top that the DUT is now connected to the DMesh route, which is the mesh node on the ground floor over 3 hops. That is over the mesh node on the second floor, then the mesh node on the first floor, and then to the mesh node on the ground floor. It is connected to the mesh node on the first floor over 2 hops, and is connected to the mesh node on the second floor over a single hop. Now we'll start the video test, where we'll run the same video that we ran on the ground floor and see how the frame drops and other stats have now changed. Now the video has ended. Now let's look at the frame drops to get a sense of how this video is played. So we can see now that the video, the frame drops over the duration of the video is around 650 or so. To give you an idea of why this is the case, we'll run the iPerf test now and show you the kind of throughputs that we're getting in this place. Now we'll run the iPerf test between the DUT and the mesh node on the ground floor. So throughput test is ended, and we can see the average throughput over 30 seconds is 110 megabits per second. So keep in mind that this is over 3 hops between the DUT and the mesh node on the ground floor. So now we'll move to how the comparison between the Qubercomm NMesh solution and the open source 11s solution stands. So now we'll disable the Qubercomm's proprietary IP by using the ANI flag on the cloud, and we'll again run the same test to show what the open source 11s performance is like. Now I'm turning the ANI flag off for the mesh node on the first floor. I'm applying the change. ANI has now been disabled for all the mesh nodes. Now we'll run the video playback test between the video player on the ground floor and the DUT on the second floor. You can see that the performance is not quite as good as the Qubercomm ANI solution. You can see a lot of distortion in the video. The video is now ended, and now we'll look at the frame drops to get an idea of how this video quality has been, how the streaming quality has been. So now, looking at this screen, you can see that there have been more than 220,000 frame drops over the last video streaming. So this is significantly much more than what we had observed with Qubercomm's ANI solution enabled. Now, to get an idea of why this has happened, let's run the throughput test now, and that will give us the reason why this has happened. Now you can see that the average throughput over the last 30 seconds is 11.6 megabits per second. This is in comparison to about 110 megabits per second throughput that we got with Qubercomm's ANI implementation. We've just demonstrated how the Qubercomm's NMesh solution is better than the open source 11s solution. And the two main reasons for it is how the path selection algorithm works. And in the Qubercomm's NMesh solution, we picked 3 hops. That is from the second floor to the first floor and then to the mesh node on the ground floor. Whereas the open source 11 mesh solution, as you can see in the screen, is connecting directly to the mesh node on the ground floor, and therefore the throughput is only about 11 megabits per second. Whereas the Qubercomm's NMesh solution provided 110 Mbps per second, and that is basically because of the path that is chosen. Thank you.